Hi, welcome to this new video about the use of the SLOODLE Tracker. In the last video we saw how the simple functionality of this plugin can be used to introduce Second Life demos in a model course. And we also completed the learning experience with some of the other SLOODLE tools. The DC generator shown in the previous video is a very simple interactive demo with two touchable frames extended with some teaching material on this panel. The demo is individual, and the SLOODLE Tracker was used to structure the experience, creating a sequence of tasks. But it is still a simple demo in which more than one avatar can interact at the same time, right? What I'm gonna show you now is a second demo located also at the Engineering Education Island. It is down there, and this is a virtual model that demonstrates the basic operations of a computer's CPU, showing how the different units of the CPU exchange data to perform fundamental operations like addition or subtraction. Many lecturers on computer science pointed that one of the biggest problems for new students is to understand this process, and this demo here provides a step-by-step execution of example program instructions, an execution managed by the user who has to touch each unity to continue the process. And there are also two different simulations. The first one is just a demonstration of the process, and the second includes an error which has to be detected. Right, so to start, the student has to come to this area where different panels provide him with general information about the island and about this particular demo. Again, a SLOODLE Rock and Roll booth allows the user to register the Second Life avatar in Moodle, and after clicking on the last poster I can choose the normal simulation or the error one. I'm gonna choose the simulation one, and all I have to do now is follow the different instructions I get in the dialog boxes. So I have to go to the first unity and touch it. As you see, each unity has its own information panel explaining its role within the CPU. Okay, so I touch the program counter and I can initialize it now. Right, the data is sent to the next unity. Here we go, and I have to go now to the program store and again touch it to continue the process. So I touch the object, and with this entry 00, I'm gonna see how the first cell is selected. Alright, the data stored in that cell is read and sent to the next unity, and I can go to the instruction register now. One more time I have to touch the object, and when I do so I get a new dialog box. The data, this 68, is now decoded, and the different fields are sent to the corresponding component of the CPU. Right? So you see how the user manages the whole execution of the instruction by touching the different objects, while the fetch, decode, and execute process is visually explained step by step. In the last part of the demo, the data is sent to the ALU, and this is the last unity I have to touch to complete the process. Right? So I touch this last component, and it reads the different entries to select the operation. For example, this entry came from the instruction register, and it's used to select the third operation, right? Okay, so once the result is ready, it is sent through the output. It goes to the register file, and one last dialog box is used by the user to reset the whole demo. The last task is answering a Moodle quiz using the SLOODLE quiz chair. We have seen how the whole fetch, decode, and execute process is managed only by touching objects, like the DC generator. And like in the DC generator, all the touchable prims in this demo are also tracker objects that are sending the interactions to Moodle, right? In fact, this is my Moodle course where I have the Second Life tracker activity for the fetch, decode, and execute demo, right? But this demo here is a bit more complex than the previous one. This is also individual, but in this case, the user starting the process is the only avatar allowed to interact with the different units of the CPU, right? In fact, I cannot touch this object here now because the process has not started yet, so I am not the registered user, and the same happens if the process is started by a different avatar, so I am not able to interact with the demo. The tracker scripts need then to know that user and only send information to Moodle when the allowed user interacts with the demo, right? And there is something else. I used the SLOODLE Tracker to create a sequence of tasks for the DC generator where a structure was not defined by default, right? But the nature of this process here already creates this sequence. In the CPU, this unit only works after the data was sent to it by the previous unit, so obviously I cannot interact with it without interacting with these units before. In this case, the tracker needs to be adapted to send the information only in the right moment. So let's see now how all this is scripted and notified to the SLOODLE Tracker, okay? The different units of the CPU are identified in the scripts, and a sequence of tasks is created by setting the unit this script is listening to, right? There is a user allowed to interact with the object, and two values are used to tell the tracker whether the unit is active or not. Again, linked messages are used for the communication between the scripts. When this particular unit is running, the tracker is notified with a linked message containing the user, okay? And once the unit starts sending data, a new message is sent to the tracker. In the tracker script, now a sequence of tasks is not defined with these variables, okay? And a flag is used instead to know if the unit is running or not, right? And only if the unit is ready and the avatar detected is the allowed user, the information is sent to Moodle. Okay? These two details, user and sequence of tasks, could be done in the tracker script as well. We could use it to define a sequence of tasks, as I did for the DC generator, and then modify it to have only one allowed user at every moment. In this particular model, the SLOODLE Tracker was added after the demo was created, so the tracker had to be adapted to the demo, not the demo to the tracker. But even if a demo is built having the SLOODLE Tracker from the beginning, I think it's always better to have the demo functionalities managed by their particular scripts and try to adapt the SLOODLE Tracker to it. For example, in a demo like this, where a predefined order of tasks is kind of intrinsic to the process, you should use the demo scripts to create that sequence instead of the functionality provided by the SLOODLE Tracker, so that the demo will work even if you decide to remove the tracker scripts. And this is it. In the next video, I'm gonna show you how the SLOODLE Tracker can be modified to track more complex activities made collaboratively by more than one avatar. Goodbye!